Hello, my name is Madi Al-Husseini, and today I'll be presenting Leveraging IoT, Internet of Things, within the military network environment, challenges and solutions. Of course, I'm a student here at Georgia Tech in the OMSCS program. My email is shown there should there be any questions that you would like asked or answered outside of just Piazza. And then I think a great way to summarize this presentation, um, if nothing else is to be taken away, is from the statement that you can often hear in IoT circles, and that's the S in IoT is for security. So just a little bit of a joke there. So just an overview. We're going to begin with an introduction and motivation. We'll discuss how integrating IoT for military application can be focused. We'll talk about 6 principal challenges, and in the paper, um, this concept of middleware and a forward deployed processing station and how that can assist the process. And then just a couple of personal slides that can either shed some light on the situation or are just quite interesting, historically speaking. So introduction to motivation. So the Internet of Things, or IoT as I'll refer to it throughout this presentation, and IoT enablers. And so when we talk about IoT, there's a few concepts that are really valued, and that's openness, accessibility, but also connectivity. And so that leads us to ask the question, well, what is IoT? Well, IoT characterizes a network of connected devices that interact and share information. And of course, true to the name, the primary platform for this network is the internet. And I think what makes IoT so remarkable is that it extends beyond just your regular phones and your laptops, which are internet-focused devices, but includes pretty much any ordinary device that you wouldn't generally have connected to the internet. And so this could mean anything. This could mean speakers, this could mean an automobile, this could mean furniture. And we'll see that that really plays a special role in the military. And what has made IoT, I think, so prominent nowadays is advances in certain technological sectors. When we say miniaturization, we often think of Moore's Law and transistor miniaturization, but also advances in sensors, so MEMS technology, and energy efficiency advances as well. So changing gears a little bit, we're talking now about the military operating environment. And as we can see, a very different set of values that aren't necessarily contradicting, but might take a little bit of effort to see the overlap. And that is security, reliability, interoperability, control, and adaptability. And you can imagine just how these would be important on a battlefield, for example. Security is, of course, particularly important when you consider an opposing force that is actively trying to harm you. Reliability is really important, both of our equipment and in each other. And you can see here an image of an Army medical evacuation mission underway. That's actually my personal line of work. And there you really expect the technology you're utilizing to always be active, and that it's always there when you need it. Otherwise, you might even lose a life. Interoperability is particularly important in a military environment nowadays. We're always fighting with the other branches, so we're always fighting alongside the other branches, I should say, of the military. So you have the Army, the Air Force, the Navy, the Coast Guard, and so on, the Marines. But we also require a certain amount of interoperability, not just within the United States, but also that's expected of coalition partners. Of course, control is quite important on the battlefield, and nowadays, when you have a multi-domain battle, whether that's through space, cyber, air, water, land, whatever the case might be, a certain amount of adaptability is also required. And so this is, I think, quite telling, and this comes directly from a military report titled The Operational Environment and the Changing Character of Future Warfare. And there they list potential game changers through 2050, and they have this concept of an era of contested equality. And they specifically state the Internet of Things, and they state linked Internet things create opportunity and vulnerability, which I think actually summarizes this presentation and the aforementioned paper quite well. And it says great potential benefits already found in developing U.S. systems also create vulnerability. So even within the military, there's this awareness of just how capable the IoT can be in military hands, but also about the importance of ensuring security and encryption is there for military use. And so ultimately that leads us to this concept of the future fight and this idea of a highly connected operating environment. And the battlefield as a sort of networked entity was really quite novel if you think about it for some time. Even today, technology on the battlefield is everywhere, but I certainly wouldn't say you have this giant battlefield as a networked entity concept where everything is connected. And I certainly think we're getting there, and I think IoT was part of that concept. So let's talk about exactly how we can integrate both commercial IoT technologies and military applications. And there's 4 areas of focus. And the first one is in sensing and computation platforms. And this is pretty straightforward. It's just the idea that military equipment and military-grade equipment already has sensing and computation capabilities, but that can be benefited and buffered by the use of commercial IoT technologies should they become commonplace. Of course, advances in underlying IoT enablers, and those have already been discussed, can actually be used to leverage not only weapons, which I think is much of what comes to mind when people consider the military, but also ships and aircraft, for example. And when we talk about IoT, as we've mentioned, there's this connection between ordinary things that generally aren't internet enabled, but a lot of those fundamental connections can even be made on the battlefield. And of course, ordinary objects on the battlefield are quite different than what you'd see in your home, for example. And we often have this concept of beans, bandages, and bullets representing food in war, medical supplies, and tools of war. And fundamental connections can be made between those. And as many military strategists will tell you, wars are not necessarily won out of bravery, but they're won out of logistics and supply battles, and how well you can maintain your supply line, and how well or how adequate your military supply is needed for the environment you're fighting in. There's definitely this concept of meals win wars, and I think IoT really can play a great role in reducing maintenance and supplying line time there, and also increasing force aggressiveness, and generally, as we've seen with the medevac image previously, supporting life-saving capabilities. I can tell you from my perspective that the placement of a medical helicopter, or how medical helicopters are placed in a general area of operations, is incredibly important for getting or having wounded soldiers or civilians or even prisoners of war moved to the closest hospital. And I think by having a lot of this IoT available, the data received from those sensors can actually do tremendous work. Now, the increased availability of information is also quite important. So the military has a tremendous slate of labs, and you've got the Air Force Institute of Technology, the Army Research Lab, ARL, the Naval Postgraduate School, just to name a few. So you've got quite a tremendous amount of resources ready to process that collected data, but embedding those technologies will play a large role in increasing that data set. And I think ultimately that will result in an increased number of policy recommendations and new products developed. And existing IoT technologies will also provide significant information in future environments of war. So the urban environment, so we've got this concept of smart and mega cities that will become increasingly prominent in the coming decades. And I think a lot of information regarding those environments can be attained from existing commercial IoT technologies. And ultimately, this will result, we can expect change in TTPs, or techniques, tactics, and procedures, and that all of this serves the purpose of improving situational awareness, being something quite critical for the battlefield in all manners. So there are 6 principal challenges when we discuss bringing together or synchronizing commercial IoT and existing military technology. And the first is communications. So IoT systems and components, they're developed for a commercial environment, and that comes with a lot of assumptions. And those assumptions generally are in regards to the availability and the stability of communication network links. But there's no IoT without the internet. And the reality is, in a lot of these environments, these tactical environments, you don't have the internet, to put it briefly. And even in the cases where you do have the internet, it's quite costly to maintain and spotty at best. And given the fact that when you do have internet, it's spotty, we know that many IoT devices are actually designed to fail to activate unless they're able to reach whatever centralized infrastructure the manufacturer designates. And this is entirely untenable in a military environment that, again, values and requires reliability above all else, with the single exception maybe being security, and that in itself is an issue we'll discuss later. There's also this concept of converged existence, and the commercial IoT world is a bit of a wild west, whereas the military technologies are quite carefully controlled but also significantly restricted. And there's quite a bit of gripe about military technology not advancing nearly at the breakneck speed of what's happening in the commercial world, but there's a reason for that, and a lot of it deals with privacy and security. So there is an almost cultural disconnect between commercial IoT and military technology, and this disconnect is quite problematic when you need the two to synchronize, and that would occur, for example, should your commercial IoT devices need to utilize military networks for traffic. And that's just one of many examples. And commercial IoT is quite susceptible and likely to detect sensitive information. And in fact, that's actually probably quite the point. So the problem is if it's collecting a lot of this sensitive information that can lead to dramatic changes on the battlefield in a negative manner, and those IoT technologies are susceptible, that'll interfere with the military mission. And what more, we begin to engage with this theory of the weakest link, where the opposing force actually now begins to target these commercial technologies for their known security weaknesses. And really, that'll blow out of the water all the efforts that have been made as far as encryption is concerned with the military technologies the commercial IoT is utilized with. So that's certainly something to be concerned about. And then interoperability. We discussed the joint force, and the military, as anyone will tell you, is built on standards. And significant heterogeneity exists in commercial IT efforts. And with this variability in design, you have quite a bit of difficulty as far as military integration is concerned. And again, IT technologies need to be adapted for military use, and they need to exist in harmony not just across the branches of the United States military or the uniformed services, but coalition forces as well. Then information filtering and prioritization. So with the current military environment, the drive to collect ever more data is not quite as feasible as on the commercial side. I think in the private world, there's this concept that the more data, the better. And to an extent, this might be true, but I think a lot of folks would question the value of data without the proper means to process it. You can collect as much data as you'd like, but without the needed lessons learned, where's that data really getting you? And I think that's even more true in the military environment, where the infrastructure for data collection, storage, and processing really isn't even remotely on par with what we have in industry. And even though previously, of course, I discussed how there's quite a few military labs involved, I would make the case that the number of data scientists per capita, I guess you could say, isn't what's needed should you have a widespread rollout of IoT technology across the battlefield. And I think in addition to that, we need to consider who will be on the receiving end of those lessons learned. And of course, that's soldiers or service members. And I think it's important that with all this data that might be incoming, should you have this IoT rollout, that you're only conveying lessons learned with notable certainty, because distracting, irrelevant, and deceptive information is tremendously harmful to the military mission. Analytics. So we rely here in the private sector on the cloud. We rely on the cloud and the concept that if we put the data there in a reliable place, we should be able to return to it without issue. But that's not always the case given the military's resource-constrained networks, and for that reason, there's a need to move data set filtering capabilities forward. And that will come into play later as the paper makes two possible solutions that can be used in conjunction to get around this. And also, and this is true anywhere, but especially true in the military, inefficient representations of data sets will eat up those already limited military network resources. So that brings us to this concept of middleware, and I take this directly from the paper when I say, in particular, middleware solutions should enable the processing of data gathered from IoT devices along communication paths, possibly at the edge between tactical and IoT network gateway nodes, or dedicated nodes providing computational resources in close proximity to the gateways, minimizing the need for cloud-based services. So, all right, so that's quite a bit, but the concept there is basically saying introducing a middle-of-the-road software, for example, between existing military technologies and commercial IoT technology can serve as a medium where a lot of that data and that information can be processed in a secure and tactical way that can then be passed on to boots on the ground, for example. And so the paper introduces two frameworks. You've got the agile computing middleware, which does much of what we just previously discussed, and that's novel methods for network communication in tactical edge environments, but also a manner in which data can be processed forward of something like the cloud. And the concept there is receive, process, forward, or SPF, and that provides integrated data filtering, information extraction, and dissemination functions. And so ACM and SPF are really meant to be utilized together, and when done so, they're capable of developing and deploying IoT services that scale with resources on devices running PIGs. And PIGs is the programmable IoT gateways, and those are dedicated nodes at the edge of the IoT and tactical network that perform those receive, process, forwarding functions. All right, so that might seem like a lot, but I think an excellent way that the paper demonstrates this is with this diagram. And here you can really see essentially this concept of your commercial IoT networks, and those are shown in the fluffy clouds. And those networks provide information to the SPF, programmable IoT gateways, or again, PIGs. And there you've got your data being processed. So this is your data processing forward, closer to your front lines, so to speak. And that feeds that information into a sort of middleware that has the necessary security and encryptions to feed directly into the front lines. Whether that's troops, Humvees in this case, whatever the case might be, because even with our Humvees, you have software involved, and whoever is actually on the ground can in turn provide requests to those SPF controllers, which coordinate with the commercial IoT networks. So here's just a couple of personal asides to wrap up this presentation, and the first is quite interesting, and this is actually something I came to the realization about after taking an Introduction to Information Security course last semester, also in the OMSCS. And there in that course, we read an excellent paper, and the title of that paper, I have it right here, and that's the design philosophy of the DARPA Internet Protocols. And it discusses how TCP/IP, which is the Internet Protocol Suite, was actually first proposed by the Defense Advanced Research Projects Agency. Nowadays we know it as DARPA, and that these protocols were actually inherently designed to meet military requirements, to include foremost survivability in the face of failure. And so previously we discussed, the values on the military operating environment, and the first one up was security. And really, at the end of the day, security really serves the purpose of retaining survivability. And so it's interesting to note that really the origins of the internet were built out of a lot of these military values and things that are valued on in a military operating environment, but how a lot of the infrastructure for IoT that sprung around the internet is anything but appropriate for military use. And really it's just kind of an interesting concept to see how the needs of the military have advanced. And that leads us to the S in IoT is for security. And here's another one, and I think this is what really motivated me to take on this particular paper, and as so many of the others were quite interesting. But one of the projects I worked on briefly when I was at NASA Ames was to develop a particulate monitoring site and also a particulate monitor. And the concept was very much cyber-physical in concept. You had the concept was to deploy a lot of these particulate monitors across the United States, and that they would upload their data to a central MySQL database, and then of course that database data from the database would be drawn forward into this processing into the site, this visualization site that you see here. You've got a simple Google API. There's a bunch of data visualization done in R and Stata and some other websites, or some other softwares I should say. But so we developed this, but we were approached with, and of course everything in this presentation is unclassified, so no worries there. But there was this concept of potentially using this site and those particulate monitors on Humvees in the Army. So when in Iraq and Afghanistan, the particulate levels are incredibly high, and that's for a number of reasons, some of which are our own, so to speak. So burn pits were often utilized not to the benefit of our service members, to say the least, and that would increase the number of particulates. But also being in that particular operating environment, you have to deal with sand, you have to deal with oil refineries, all processes which lead to an increase in particulates. So it's this concept of using this particulate monitor on different Humvees, databasing that information, and having a way to track it for military strategists to use in their military operations. Now, of course, that actually never got off the ground. That conversation didn't go too much further for a lot of the concerns that were actually mentioned in this presentation. So that's quite interesting. Here we have references. Again, we've got that Design Philosophy of DARPA Internet Protocols article. It's really an excellent read. We have Analyzing the Applicability of Internet of Things to Battlefield Environments. Again, another look of how we can synchronize the two. Of course, the paper on which this presentation was built, which is Leveraging Internet of Things within the Military Network Environment. And then finally, the military report that we drew from earlier on when we had our background section, and that's the Operational Environment and the Changing Character of Future Warfare. Pending any questions in the Piazza, I look forward to having a conversation with you. Should you have any questions? Thank you very much.